good evening, everyone. Uh, we will be starting our today's session. Okay, today we will see how to find out eigenvalues for okay, eigenvalues, an eigenvector. Then we will see Kirchhoff circle theorem examples. Okay, and we will see power methods and inverse power method to find eigenvalues. Okay, this will be the today's session. Okay, we will solve problem based on this, and I will also try to finish off the second method which was remain in the previous session. Okay, so let's start with our first problem. Okay, please let me know what are the things which are already taught in this week among these three topics. Are all these three topics already covered in this week? Hello, are this topic already covered? You were present, right, in this week? Are these topics covered in this week? Whatever I have written on this screen, are these topics are covered? Are you getting what I am asking? Anyone? Are you aware that these topics are already there and already covered in this week or taught by the professor? Uh, Matumita, are you there? Matumita? Hello? Any one of you, please let me know whether these topics are covered or not. Anyone? Hello? Are these topics covered in this week? Raga Priya? Yes, tell me. Are these topics are covered? Raga Priya? Please let me know in the chat box or unmute your mic. Are these topics covered? Anyone, Archu, Divya, Gomati, Sonia, anyone? This Vegeta, 62 Vegeta. No one is responding. Why no one is responding? Were you not there in the classes? Hello, Raga Priya? Yes? Hello, Gomati? Hello? Why no one is responding? How I will know? Are these topics are covered? Okay, 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 okay. Then we will start. Okay. So first question. You are aware of eigenvalues and eigenvector, right? So before starting, you know, for finding eigenvalues, we need characteristic equation, right? Which is here if A is the matrix, then and lambda are the your eigenvalues, then A minus lambda I is equal to 0 is your characteristic equation, right? And this gives you eigenvalues. And from eigenvalues, we calculate corresponding eigenvectors. Together are called as pair of eigenvalues or eigensystem, right? So first question, find the eigenvalues and eigenvectors of matrix A. Also find trace of matrix A, where your A matrix is given as A is equal to 1 1 3, 1 5 1 and 3 1 1. Okay, so we have to find out the eigenvalues and eigenvectors of this along with the trace. So anyone know what is the trace? What is the trace? Trace of the matrix? What is the trace of the matrix? What is the trace of the matrix? Anyone? Divya? What is the trace of the matrix? Trace of the matrix. No one knows. Trace of the matrix is sum of eigenvalues. Okay. So let's find out. First, we will for finding out we need first characteristic equation. Okay. So characteristic equation, right? So are everyone following me? Right. Subtracting eigenvalue from diagonal element, right? Lambda. We compute this. Okay. So 1 minus lambda into 5 our like we find out the determinant. We are finding the determinant, right? So how we will find 1 minus lambda is determinant, then plus minus 1 1 1 3 1 minus lambda plus 3 1 5 minus lambda 3 right? Is it correct? Is it correct?
Yes, sir.
Okay. Give me the equation of characteristic equation, please. You simultaneously work out everyone. 1 minus lambda 6 lambda plus lambda square minus 1 plus minus 1. Oops, little small. Is everyone following, right? This is very simple finding of the determinant, right? What is the equation? What is the equation? Get 1 minus lambda, get equation in terms of lambda, right? So 5 minus 14 plus 3 lambda, lambda square minus 6 lambda plus 4, 1 lambda 2, lambda square minus 4 lambda plus 2 plus lambda minus 42 plus 9 lambda. Correct? So, what is the equation? So, we will take common. So, minus lambda cube, minus lambda cube, uh, lambda square. Yes, is it correct? Whatever I have written, is it correct? Did everyone got the same characteristic equation? Is it correct? Did everyone got the same equation? Lambda cube minus 7 lambda square plus 36. Right? Is it clear up till this? And this is your power 3 equation, right? So how will you factorize this? You need some divisor method, right? This is not our normal quadratic equation. This is our third power equation. So we need some divisor method. So just follow. This is very important to find out the factors. Are you aware of this method? How to factorize this? Can anyone tell me the values after factorizing this? Okay. Uh, so 1 minus 7036, right? This is your third power, second power, first power, constant. So we have to take the factor here such that it should be 0. So what value we can take? We take 2, say we take 2. Okay. Will 2 work? 2 will not work, right? Is this equation correct, first of all? Before even factorizing, is this equation correct? Is it correct? Everyone got the same characteristic equation? Lambda cube minus 7 lambda square plus 36. Gomati, did you got the same? Other people also can respond. Rajendran Komala, did you got the same characteristic equation? Okay, I guess this is very simple. Everyone must have got this thing. Komati, Divya, please respond in the chat. What are the eigenvalues after factorizing? You got the characteristic equation. Let me know the eigenvalues. So we'll use this method. Minus 2, that means our factors are lambda plus 2, lambda square minus 9 lambda plus 18 is equal to 0. Then further factorize this thing. Please let me know if there is any doubt. Okay. Right. So what are the eigenvalues we got? We got eigenvalues lambda is equal to minus 2, 6 and 3. Right. So these are the eigenvalues. Okay. What will be the trace? What will be the trace of the matrix A? Sum of these eigenvalues. It's minus 2 plus 6 plus 3 is, and minus 2 is 7. Okay. We got our one answer. We got our first answer is eigenvalues minus 2, 6, 3 and trace of the matrix we got. Now we will find out corresponding eigenvectors of the eigenvalues. Okay. So first eigenvector for lambda is equal to minus 2. So what we do? We substitute lambda is equal to minus 2 in this equation 1, right? Okay. So your will become this 1 minus of minus 2 1 3 1 5 minus 2 1 3 1 sorry minus of minus 2. Okay, 1 1 minus of minus 2, that is plus 2. Okay, this will be your corresponding eigenvector. Okay. So put it as x1 x2 x3 equal to 0. Okay, so 3 1 3 1 7 1 3 1 3, right? So we will to get this, we will try to convert it into row echelon form to get the relation among the x1, x2, x3, and will help to get the eigenvector. Okay, so we know we have to make this one, right? We can simply interchange these rows. Okay, and again we will interchange with these rows. Why we are doing this thing? Because matrix doesn't change if we do any two two row operations or column operations, right? This is the rule. So we'll just interchange 171. So what we will do? We will do R1 gives R1 replaced by R2. Oh, sorry, R1 replaced by R2, and R3 is replaced by new R2. Okay? So we'll write 171 goes up, 313 goes down, and again that goes to third row. So second and third row will be 313, 313. Okay, then x1, x2, x3, 0, 0, 0. Okay, now what we will do? We will uh, try to do these zeros, right? So what operation we need? R2 gives R2 minus 3R1, R3 gives R3 minus 3R. Right? So what we get? 1 0 0 7 1 will be as it is. 1 minus 21, right? 1 minus 21 minus 20, 3 minus 3 again 0, minus 20 again 0, right? Correct? So, x2 x3 0 0 0, right? Now what we will do? We will make this 0. How we will make this 0? What we want? We want row echelon form. That is upper triangular matrix form. For we want upper triangular matrix. Okay. So R3 gives R3 minus R2. Right. 1 7 1 0 minus 20 0. This will be 0 0 0. Okay. So 1 x2 x3. Right. Is these things are clear to you? Now, as this 0 is entirely 0, we will not consider. We will have only two equations. Okay, as this is complete row is 0. So we will get relation from two equations because we know the rank of this matrix is what? How we calculate rank? The rank of matrix is number of non-zero rows. How many non-zero rows are there? There are two non-zero rows, this and this. So rank of the matrix is 2. So we will use these two equations. Okay. So from these two equations, what we get? x1 plus 7x2 plus x3 is equal to 0 minus 20 x2 is 0. So this implies x2 is 0. Okay. This implies x2 is 0. So we'll put this x2 in this first equation which we got. We will get x1 is equal to minus x2. Right. So how will we calculate eigenvector? We just put one value for x1, and we will get values for others, right? So x1 is 1, x2 is 0 already, and x3 will become minus of x1, that is minus 1. So eigenvector is 1, 0, minus 1. This is eigenvector for eigenvalue minus 2. Are you getting? Hello, everyone?
Yes, sir.
Are you following that? Okay. Please, similarly, you calculate the eigenvector for 3 and 6. Okay. I'm calculating simultaneously, but you also calculate and tell me the answer. Okay. For 3 and 6. Okay. You calculate eigenvector for 3 and 6. Eigenvector for lambda is equal to 3. So what we do, we substitute again. Lambda is 3, so I'm directly writing now 1 minus 3 is minus 2, 1 3, 1 5 minus 3 is 2, 1 3 1, 1 minus 3 is minus 2, right? Okay, x1 x2 x3 0 0 0. Okay, again we will try to make it quadrangular, or we say row echelon, to get eigenvector. Okay, so again we will do the same thing. We'll replace R1 with R2 and R3 with new R2. We'll just for your, okay. So what we will get, 1 2 1, 3 1 minus 2 minus 2 1 3. Why we are doing this? To get row echelon form. Okay. We have already one in first column, so we will just do the row operations. Okay. Now we have to make these two things 0. So what we will do, R2 gives R2 minus 3R1, and R3 gives R3 plus 2R1. Okay, so we get 1 0 0 2 1 minus 6. 1 minus 6 is minus 5. 1 minus 6 is minus 5. Then 1 minus 2 plus 2 0. 3 plus 2 is 3 plus 2. What we get? Is anything wrong I have done? Oh, okay, okay, okay. I operated column wise. Okay. Should be row wise. We are doing row operation, right? So 1 minus 6 minus 5 minus 2 minus 3 is again minus 5. 1 plus 4 is 5. 3 plus 2 is again 5. Very nice. Okay. Again, then we will make this 0. We get a triangular, right? What we will need, R3 gives R3 plus R2, right? So R3 gives R3 plus R2. We get our upper triangular form. Now we are ready to calculate. What is the rank of this matrix? What is the
Two, sir.
rank of the matrix? It's 2. Okay. The rank of the matrix is 2. Correct. Correct. That is correct. Uh, okay. So what are the eigenvectors? What eigenvectors? Anyone? Anyone calculated? Has anyone able to calculate? So again we will do the same thing. This one is 1. So x2 will become x2 will become or okay, we will not take for whole values. I have written wrong. Right? Oh, is anyone listening? No one can. No one is there, I guess. No one is able to identify mistake.
Yes, sir. X2 equal to minus 3, sir.
Yes, yes. Okay, then we will put so x1 is equal to right is equal to minus x2 is equal to minus x3. So if we take x1 as 1, x2 will be minus 1, x3 will be 1. So eigenvector, what is the eigenvector? Eigenvector for eigenvalue is equal to 3 with 1 minus 1 1, right? Now eigenvector for eigenvalue 6 I want from you. I will be doing simultaneously, but I want from you, answer from you. Okay, calculate eigenvector for eigenvalue 1, eigenvalue sorry 6. Okay, please calculate and tell me the answer. For your simplicity, I will just write first step. This eigenvalue 6 is 3, minus 1, 3, 1 minus 1. Anyone will calculate and please let me know once you have calculated. Once you have calculated the value and found out the eigenvector, please let me know. Okay, eigenvalue 6. I want answer from you. Take your time, do patiently. Everyone has followed the previous means previous eigenvalues which we have calculated and their corresponding eigenvector, right? You have to follow the same steps and you will get the eigenvector for eigenvalue 6. Okay. Okay, what will be the operations? To hmm, if anyone is finding any kind of difficulty in understanding, please let me know. There is nothing complicated in this. You have to just do the basic mathematics So R3 gives R3 plus 5 R1, R2 gives R2 minus 3 R1. So 1 minus of minus 3, 4 minus 5, minus 3 is minus 8. 1 minus of 5 is minus 4. 3, 3, sorry, again, I will do the same thing. Okay. R2 is minus 8, 1 minus minus 4, minus 5, minus 3 is minus 8. Okay, so 1 minus of 5 is minus 4, 3 plus 5 is 8, so 1x2 is 3. Okay, so we'll get 3 plus R2, echelon form. Almost you can see the steps are very similar. You practice it, will be very easy and you'll be faster. More you practice, more you will be faster computing these eigenvectors. Okay, so we get now I want answer from you. What are the eigenvectors? Hmm. Has everyone solved this eigenvector thing for eigenvalue 6? What is the answer? Rajandharan, Rajandharan Komala. Sorry if I'm pronouncing it wrong. Okay. Are you there, Rajandharan? Is not there. Anita, Anita is there?
Yes, sir.
Yes,
There.
yes. Did you calculated the eigenvector?
No, sir. I'm doing it.
Okay, okay. You are following, right? You are getting the things?
I had joined somewhat late, sir, but I had some idea. I'm doing it.
Okay, if you find any difficulty, please let me know. Okay.
Okay. Sir. So, can you shift the screen somewhat up, sir?
Okay, you want the previous steps?
Yes, sir.
Okay.
Thank you.
Till what?
Down, sir.
Down. Okay. Okay. Divya
Thank you.
Bharti.
Sir. Thank you.
Divya Bharti, are you there? Divya Bharti, not there. Okay. Who is there then? Okay. The Divya Bharti, do you got the answer of eigenvector? You got the answer. If I am fast, please let me know. Okay. Take your time, but compute the answer correctly. Anyone? Komati? Komati is there. X1 is 2. X1 is 2. 1, 1, x1 is 1. Okay, Divya, the answer is correct, but there is slight uh, silly mistake you have done, I guess. X1 is 1, and which two values are the same, Divya? Your answer is correct, but you have
So
shift.
my typing mistake, sir. X1 and X3 equal to 1,
Yes, yes,
X2
correct,
equal
correct,
to
correct.
2,
Yes, yes,
sir.
I understood. Just I was confirming. Okay, the eigenvector for the 6 is 1, 2, 1. It's correct. Yeah. Everyone got? Komati, did you got the answer? Komati, Gomati, and who is there? Raga Priya. Everyone got this answer?
Sir, I didn't understand. Once again, tell me, sir.
Okay, I am again. Where you are finding difficulty?
Eigenvector, sir.
Eigenvector. Yes, eigenvector. Should I tell you entire thing? Okay. See, in eigenvector, what we do, first step is we for we calculate eigenvector for a particular eigenvalue. Okay. So what we do, we subtract eigenvalue from diagonal elements. Okay. We write it in this form. Okay. This is your first step. Okay. You have a matrix. Okay. So say for example, see this. We have this matrix. Okay. 1 1 3 1 5 1 3 1 1. So from diagonal element we will just subtract the eigenvalue. Okay, this will be the first step. Okay, for we will subtract that eigenvalue for which you are calculating eigenvector. Okay, after doing that you will get, say for eigenvector lambda minus 2, we subtracted minus 2, right? Okay, subtracted minus 2, that means we are adding 2. Okay, so diagonally, then we will get this form. Okay, is this clear? Is this clear, Komati?
Yes, sir.
Okay, after that, what we will do, we will try to get the row echelon, or we say upper triangular matrix form. So we want form of this. So what we will need to do, we need to make this 0, this 0, this 0. Okay, okay, you are
Yes, sir.
following? Okay. So what we did, like we make this first element 1, then 0 0 and 0, right, in upper triangular matrix we try to do this. So we have already one, correct? We have already one. If we do the row operation and simply swap the rows, still it will work. Okay, we know the rule of matrix, that if we means swap any two rows or column, we interchange any two rows or column, the matrix remains the same as original. Okay, so what we are doing is we are replacing the first row with second row. So in this, for example, in this we will do first 1 7 1. Okay, you are able to see what I am writing? Are you able to
Yes,
see?
sir.
Yes. 1 7 1 3 1 3, which was the first row, and last row was 3 1 3. Okay, this is first row of interchange. Again we will interchange second time. What we will interchange now, this and this, but both are same, right? So that will
Yes,
remain
sir.
as it is, right? Right?
Yes, sir.
After this, what you do, you make this 0 by simply these operations R2 minus 3R1, R3 minus 3R1, right?
Yes, sir.
Then you will try to make this 0. How you will make this 0? You have to add the things because both, sorry, subtract the things. Both are same values, right? R3 and R2 are the same way, having the same values. So you will simply subtract, so you will get the 0, right?
Yes, sir.
Okay, you got this. Then you understood this rank thing, right?
Yes, sir.
Okay. Then you find out these two equations,
Yes, sir. Fine.
eigenvector, right? Now, is it clear now? The find method of finding eigenvector, is it clear?
Thank you, sir.
It is clear, right? Means, are you still in the confusion?
No,
Yeah.
sir.
Okay. Even if you are confused now also, still I will explain again. Okay. So let's go to the second. Okay. It is clear, right?
Yes, sir. Clear,
Okay.
sir.
Okay. Okay. Let's find. Do you know the Greshgorian circle? Greshgorian circle, right? Greshgorian circle theorem, everyone. What it tells that all the eigenvalues should lie in union of Greshgorian disks. Greshgorian disk. This Greshgorian is a Russian mathematician. Okay, so he has invented this theorem, and it has various applications. Like you can check whether matrix is invertible or not, or mainly it is used to find out the range in which eigenvalues will lie. Right? So how we calculate, how we find, we check eigenvalues, this diagonal elements, whether these are less than the values of other non sum of the absolute values of non-diagonal elements. Okay. You know, the diagonal element will have both the index same. This index will be same, right? Like 1 1, 2 2, 3 3. These are diagonal elements, right? So this will serve as a radius of Greshgorian disk. Okay, and we have to check this for every row. Okay, so I will explain this through one problem. So question is, find the range of eigenvalues of matrix A, okay, using, okay, my handwriting is, find range of eigenvalues of matrix A using Greshgorian circle theorem. Okay. Your matrix A is what? 1 2 1 6 minus 1 0 minus 1, sorry, wrong, wrong matrix. Matrix is 1 1 minus 1 3 2 4 minus 1 4 2. Okay, we we know the eigenvalues. How we can compute the eigenvalues? Okay, but without computing eigenvalues, we can find out range in which the eigenvalues will lie. Range, you can say range or bound. Okay, using this Greshgorian circle theorem. Okay, so what are our diagonal elements? Diagonal element are this, right? So according to the Greshgorian theorem, so radius of the circle will be sum of the off diagonal element, sum of the magnitude of off diagonal element or absolute value of off diagonal element. So for say row 1, okay, the dimension of this matrix is what? 3 by 3, so 3 square matrix. So we will get 3 discs. Okay, each for a particular row. So for row 1, we will get one disk, which will be carefully, please listen this. Okay, so your first is lambda minus 1 less than of diagonal. These are the radius. This is your radius. This is the radius of your Greshgorian disk. So it should be less than what, 2, right? So what it implies, lambda should lie within which range? Either it should be, or it should be, that is, right, this absolute has two values, plus or minus, right? So you just give plus or minus to right hand side. So lambda will be either, lambda will lie at least, the maximum will be 3, sorry, maximum will be 3 and minimum will be uh, plus 1 minus 1. Okay, so lambda will lie within within -1 to 3. This is one eigenvalue. Okay, this is for one eigenvalue. Now we have 3 by 3, so there will be 3 eigenvalues. And what theorem says, all 3 eigenvalues should lie within the circles of, within all circles of Greshgorian. Okay, so we get this one circle of Greshgorian. If we try to uh, pictorially represent, say this is one, okay, so we have radius 2. Now the center is this. What is the center? 1 comma 0. Center is this. Okay, center is this, and radius is 2. It will be till this, within this. Just drawing this. This is our one Greshgorian circle. Okay. Similarly, we can calculate for row 2. Can anyone tell me what will be the Greshgorian radius for the row 2? Greshgorian circle radius. This is 2, right? This is 2. We have calculated this radius, right? So please anyone tell me for row 2, which is the second disk Greshgorian, what will be the radius? What will be the radius?
Modulus 3 plus modulus 4, sir.
That is how much?
7.
7, right? And for row 3, what will be the center of the second row gross gradient is? Divya, what will be the center for the second row gross gradient is? Center of the circle.
Sir, I have one doubt that
Okay, tell me.
in the row 1, lambda equal to
Okay,
lambda
row
equal
1,
to minus can we get it, sir?
in row 1,
Yes, sir.
yes, row 1, what you have doubt?
Lambda minus 1, we add some.
Lambda minus 1, then what you have? This is according to the theorem, okay? This lambda minus
Yes,
1,
sir.
okay, mod of lambda minus 1 should be less than sum of the modulus of off diagonal elements. Okay, this I have written. This is the theorem.
Yes, sir.
Okay, this gives you the bounds in which your eigenvalues will lie. Okay, so lambda minus 1, this is your diagonal element for first row, right? What is the
Yes, sir.
diagonal element for first one? This thing, this one is,
1, sir.
right? So lambda for 2, what is the diagonal element? For
Sir,
2, for 2, what is the diagonal element? Diagonal for row 2.
3 and 4.
Off diagonal, these are off diagonal, right? That is
Yes,
off diagonal. I asked you diagonal, right? Okay, 3 and 4 is, and for third it is 2, right?
yes, sir.
So you can now calculate using this theorem, you can calculate the radius of the Gregorian disk of that particular row, right?
Yes, sir.
Okay, so tell me what is the center of the circle for Gregorian disk of row 2? This is your center, right? Center is what? 1 comma 0 for this. So what will be the center for this? Anyone? Center of the circle, okay, values are all real, right? These values can be complex also, okay, but when we are plotting this is your real axis, okay, this is your imaginary axis, okay, means if you have value say 1 plus I, okay, so you will plot it like 1 comma 1, then that will be say around here 1 plus I, okay. Okay, so now here all values are real, so values will be plotted on real axis. Okay, so uh, when you write, say for example, you remember the uh, equation of the circle. What? How we write equation of the circle? X minus x0, y minus y0 square is equal to r square, right? This x0 and y0 are the origin coordinate of origin of the circle, right? Center coordinates. So when we plot on xy, okay, so say this is some x0 and this is some y0, right? And we have some radius r, so right? These are its center coordinates. Similarly, if we compare this with this, so this is your lambda minus 2 is like x0. This is the value by which your origin is shifted. Okay, it is shifted to the right. Okay, minus means it is shifted to the right. Okay, because by convention this is minus. Okay, so you will take this amount by which it is shifted. So amount by which it is shifted is plus 2. If this was this thing, say now for lambda minus 2, your center is what? 2 comma 0. Okay, now suppose it was, say, the value of this 2 was supposed to be, say, minus 2. So what would it have been? Lambda plus 2, right? So in this case, what would have been the center? It would be minus 2 comma 0, right? Are you following? Are you getting what I am
Yes, sir.
trying to say?
Yes, sir.
This is
Yes, sir.
shift of the origin, right? So for row 3, what will be the center of the Gregorian circle?
4,0.
4 comma 0, right? And what is the radius? What is the radius? For row 3, what will be the radius?
3, sir.
So tell me the bounds for the lambda in row 2. Like we calculated bounds, this bound. Please tell me the bounds for the row 2 and row 3. What will be the bounds? In which values it will lie?
Minus 5 less than or equal to lambda,
Minus
less than or equal to 9.
Minus 5 to
9, sir.
minus 5 to 9, correct? And for row 3,
1 less than lambda less than or equal to 7, sir.
1, what
Less
you,
than or equal to lambda less than or equal to 7.
1 less
Lies
than,
between 1 and 7.
someone, okay. What you tell 7 and say okay
1,
1,
sir.
1 and
1 answer.
so we have to take union of all these three, which will give you final bound in which all the eigenvalues will lie. So what are these three values? Minus 1 for row 1, then please tell me for row 2 and row 3 what is it, and 1 7. So what will be the union of this? Means least, what is the least value in all these three? Least limit, lower limit, lowest possible limit. What is the lowest possible
Minus
limit?
5, sir.
Minus 5. And what is the highest possible limit?
9, sir.
9. So this is your final answer. This is the range of eigenvalues of matrix A in which all values will lie. Right? If you plot it geometrically like this, you will understand it in more practical sense. Okay, like we did in for the lambda is equal to, for row 1, right? Okay, so this is your Gregorian circle. One more problem. Now we will take problem on power method. Okay, you know power method, right? Everyone knows power method. What is power method? Why we use power method? Mallar VG. Are you there?
Don't know, sir.
Don't know. Okay. Raga Priya, anyone? Okay, I will tell you. Power method.
Sir, I had a doubt, sir, in the previous problem.
Yes, yes, tell me.
In the row 2, if at all we want to draw the circle, sir, we take the center as 2, comma 0.
Yes.
But what could be the radius, sir?
What could be the radius? You by yourself tell me what will be the radius?
Will it be 7, sir?
It will be 7, right? Because the theorem tells that this is your radius, right?
Okay, sir.
This is your radius, your,
Oh, okay. Thank
right?
you. Clear, sir. Okay.
Eh, Clear? So, according to that, if you try to plot, if you try to plot, okay, just for your clarity, I am telling you, okay, if you try to plot it, if you try to plot it, what is the center? What is the center? Hello, Anita?
Sir,
Yes, 2 is the center, right?
uh, yes, sir.
Radius
2
is
is the
7.
same.
So what will be
7.
its extent?
Uh, Pardon, sir?
What till what value it will extend if it is a circle?
Uh, till 9, sir, towards
Till 9.
positive x-axis.
And here,
Towards the negative x-axis, minus 5, sir.
right? And you will draw a circle,
Mm,
right?
yeah.
This is our bound
Yes, sir.
also,
Yes.
right?
Yes, sir.
Oh.
Mm.
So all every value is within this minus 5 to 9, right? So all
Okay, sir.
eigenvalues will lie in this, correct?
Yes, sir.
Oh.
Mm.
Okay, what is power method? Okay, like we calculate eigenvalues, these are the ways we human human calculate eigenvalues. We can do these mathematical operations, okay, but we cannot explain this to our computer. So to able to calculate eigenvalues computationally, there are these methods like power method, inverse power method. Okay, so to computationally find eigenvalues of matrix, okay, we use power method. Okay, this is very simple method. Okay, this will not take much time. Okay, so we will explain this through one example. Say we want to find out eigenvalues of matrix 1 minus 3 2 4 4 minus 1 6 3 5. Okay, okay, this method gives you the largest eigenvalue. Okay, largest eigenvalue. Okay, so if you want to find out this, the step is step 1. What is the step 1? Step 1 is here, these are iterative methods. Okay, so in every iterative method we know what we do. First thing, we have some initial, we take some initial guess. Here we take initial guess of eigenvalues, that is x0 say 1 1 1. Okay, correct. Then step 2, what we'll do is first iteration, we calculate eigenvalues of first iteration. How? Simply by multiplying that matrix with the initial guess. So we'll get ax0 as 1 minus 3 2 over 4 minus 1 6 3 5. Okay, now please tell me what will be the dimension of the matrix after this. We are multiplying two matrix, right? If we are multiplying two matrix, we will get some output matrix. What will be its dimension?
3 by 3, sir.
3 by 3 for this.
Yes, sir.
Are you sure?
One, one, two.
Are you sure?
3 by 2, sir.
3 by
1.
3 by 1.
1.
Correct. 3 by 1. Right? You are doing with the product. So 3, 3, 3, 3, 3 by 1. Correct? So what, tell me the value of the product for this. What will be the value of the product? You know the product of the matrix, right? We will multiply first row with this. 1 into minus 3 plus 2 is 0. Then second row 4, 4 minus 1, 8 minus 1, 7, 6, 3, 5. 6 into 1, 3 into 1, 5 into 1. 9 plus 5, 14. Right?
Yes, sir.
Now we will take largest value common to get eigenvector of first iteration. For this iteration I am telling, right? Okay. So what is the largest value? Largest value is 14 here, right? We take common 14. What we will get? We will get, right? Right. This is your, the 14 is your eigenvalue, largest eigenvalue, and its corresponding eigenvector is this. This is what after first iteration. Okay. But similarly, we have to calculate subsequent iteration till what? What we do in iterative methods? We calculate till we get the same results in consecutive iteration. Means till we reduce the error, right? Are you following what I am trying to say?
Yes, sir.
Yes. So can you compute second iteration? What we did, we take this x0 multiply with the matrix, we got the one value, we took largest value from it to get the largest eigenvalue and eigenvector of that address. So now your new x will be, this will be your new x0, means we can say x1. Okay, so in second iteration, okay, a x1, again same a. What will be the a? 1 minus 3 2 4 4 minus 1 6 3 5 0.51. You will not take 14. Okay, so tell me the value. Tell me the value in the second iteration. Tell me the value in the second iteration. Product value ax1. It's very simple. Okay, calculate and tell me what will be the value. 1 minus 3 2 4 4 minus 1 6 3 5 0 0.5. Okay, anyone? Raga Priya? Most of the people actually not getting whether they are understanding or not. Divya,
Sir, I'm calculating, sir. First one is 0.5.
first one is 0.5, right?
Next 1
Next
and
one,
2, sir.
1 and 1
2.
and
5.5, sir.
again calculate.
6.5, sir.
6.5. Okay, what we will do the next?
Uh, Take common of the highest numbers value.
So
6.5.
what will be the new eigen value and eigenvector? What is the eigenvector we got on second iteration? What eigenvector? Calculate and let me know. 6.5 you have taken common, so zero point 0.5 by 6.5, right? By 6.5, 0.0692. Oh, sorry, 0.7692. Similarly, next, what is the next value?
0.1538, sir.
0.1538, correct. And finally, now, did you achieve the good error? No, means error is less, not less, right? Between the first and the second, we will see the difference between these values and these values. There is great, the third value is okay, but there is great difference in the second value, right? So we have to take one more iteration, right? There is also error in this and error in this, right? So we have to reduce to some 10 raised to minus 3 or some, right? There will be never absolute zero, okay? So you got, this is your x2. So calculate for third iteration. A into x2 we got 0.7692 and 1538 and 1. So what did you got? What did you got? These are very simple. Right? Nothing difficult in this. So what? Product values. AX2 is 1 minus 3, 2, 4, 4 minus 1. Okay, yes,
So
yes.
second is minus 1.3845, sir.
First value is
Minus 1.3845, sir.
minus 1. Please check.
1.6155, sir.
Again check. What value you got? 1.6155, right? 1.6155. Who told me 1.6155?
Yes, sir, I got one
Yes,
point.
yes, yes. Correct it is. Then next value
minus 0.07712.
Minus 0.07712. Okay, let me check. 0.00077712. Right, right. Minus, right? And final value
5.922.
5.922, right? So, what is the largest?
5.9.
So, the respective eigenvector, is
Zero point 2727, sir.
okay. Next,
Minus 0.013.
right. So, likewise, you understood this method, right? You go on doing this, you will converge to some value. Okay. So, that will be your eigenvalue, and that corresponding eigenvector will be the required eigenvector. That eigenvalue will be largest eigenvalue. Okay. Okay. Is this method clear?
Yes, sir.
Okay. Uh, you are supposed. What time they told you to be for the this problem solving section? Means for how much time I have to
5 to
take?
6, sir.
5 to 6 is okay. They have already exceeded. So our second method is remaining, right? So second method is remaining. Take actually last time there was certain confusion for second method. Okay, slight confusion. Whatever previous method I have explained, that was correct. Okay, the formula for this and bisection is same, right? That is this. But bisection method is your bracketed method. Okay. Are you remembering bracketed method, open method? Bracketed method always converges. Okay, open method keeps on doing iteration. So these are open method. This is open method, and we have to take the values of the previous iteration into next iteration. That's it. That is the only difference. We need not have to check any sign of the function or anything. We just simply go on doing. Okay, I'm just solving one iteration for you, and you will get the things. Okay. So question is f of x is x cube minus 5x plus 1. Okay, this is non-linear equation. Okay, the initial guess is 0 and 1. Okay, so we will say for first iteration we will get value x2, right? X1, sorry, x0 f of x1 minus x1 f of x0 upon f of x1 minus f of x0, right? Are you following this? Getting this from the formula?
Yes, sir.
Okay, this is first iteration. Okay, so what will be the f of x1? Just substitute 1 in this equation, so 1 cube minus 5 plus 1, so 2 minus 5 minus 3, right? And f of
Yes, sir.
x0, you will substitute 0, it will be 1. So what will be the value of x2? This is 0, this one is 1, f of x0 is 1, upon f of x1 minus 3 minus 1. So it will be 1 by 4, this 0.25. Okay, you got x2. You will find out corresponding function value. This 0.25 cube minus 5 into 0.25 plus 1. Okay, what will be the value? Can anyone calculate? What is the function value of 0.25?
Minus 0.
Minus 0.234.
Correct, correct. Okay, this is first iteration. Okay, then second iteration, what we do? We calculate x3 based on x2 and x1. Here we calculate x2 based on x0 and x1 which were given, right? Now based on x2 and x1 we will calculate x3. Similarly for third iteration we will calculate x4 based on x3 and x2. You will get x3 from here, right? Are you getting what I am trying to say?
Yes, sir.
Okay,
Yes,
so
sir.
just I am showing you in this one iteration. Okay, so you get this value of x2. Okay, and this is your x2. We are trying to find the roots, right? So we will do the iteration till this f of f, this f values which we get in one iteration, and next iteration there should be not much difference. Okay, then that corresponding x will be the root. Okay, are you getting what I am saying?
Yes, sir.
So for next iteration we calculate x3 is equal to, right, correct?
Yes, sir.
So we compute x3. So what is our x1? 1. What is our x2? 0.25, right? This is your x2. So 1 f of 0.25 minus 0.25 f of 1 upon f of 0.25 minus f of 1. We have calculated f of 0.25. This is this, right? Is I am going very fast?
No, sir.
Okay, 0.25. So 1 minus 0.2343 minus 0.25 into f of 1 we have. This is f of 1. Sorry, this is f of 0. This is f of 1, right? We got f of 1, 1 minus 5, 1 minus 3, right? So f of 1 is minus 3. So minus 3 upon minus 0.2343 minus of minus 3, right? What is the x3? Can anyone calculate? What is the x3? Minus 0.2343 minus 0.25 into minus 3 upon. Did you got the value? We found out second iteration x3 from x2 and x1. Okay, so x3 is x1. What?
0.7337.
Again check. F of 0.25, f of 1, f of 0.25. We have to subtract below.
Minus 5.20102, sir.
Again check. This is minus 0.23. X3 value
0.355.
again work out. There is some slight
Minus
mistake.
0.30433, sir.
No. You are doing some calculation mistakes. Just keep notice about the signs. Is it correct? See, minus 0.2343 plus 0.25 into 3, right? Upon 3 minus 0.2343, right? Anyone calculating? Anita, are you calculating?
Sir, just now I brought calculation
Okay,
doing.
okay, okay. Okay, Divya, yes.
Minus 0.15944, sir.
No. Gomati calculated the correct answer. Gomathi. Yes, Gomathi, what is your answer?
Sir, yes, sir. My answer also 0.18646.
Yes, 1864. Correct. So calculate the function value.
0.073987, sir.
0.07447. Okay.
Okay, sir.
You will keep on calculating. Okay. And you eventually the values of this f and previous f will get reduced, and then that corresponding x will be your root. Okay, this is very simple. Okay, how did you understood?
Yes, sir.
Did everyone, yes, Anita.
Understood, sir.
uh, if is everything clear whatever I taught you today?
Yes, sir.
Okay, if you have any doubt, you come across any doubt during the week, let me know during the next session. Okay. Okay, thank you everyone, have a nice day.